laminar flow. This laminar flow, as we discussed, the fluid will be having two different types of flows, that is laminar flow and turbulent flow. What is a laminar flow and what is a turbulent flow? See, this is an ordered flow, that is there will be high viscosity and low velocity. This type of flows, organized flows, ordered flows, where high viscosity is low velocities in the flow is been obtained, you call it as laminar flow. Laminar flow or turbulent flow is being classified based on Reynolds number, that is rho v d by mu. Rho v d by mu. See, the Reynolds numbers, the ratio of inertia force to viscous force is called as your laminar flow. In this laminar flow, we are going to classify the flow based on the velocity of the fluid particles. See, in case of laminar flow, as I discussed, there will be high viscosities and low velocities, and the flow is classified based on Reynolds number. The ratio of inertia force to viscous force is called as Reynolds number, which will be formulated as rho v d by mu, where rho is the density of the fluid particles, mu is coefficient of dynamic viscosity, d is the diameter of the pipe, and mu is the flow is classified on based on Reynolds number, that is rho v d by mu, where rho is the density of the fluid particle, v is the velocity of the flow, d is the diameter of the pipe, and mu is the coefficient of dynamic viscosity. Based on this Reynolds number, that is, if Reynolds number less than 2000, we call it as laminar flow, greater than 4000, you call it as turbulent flow. You have something called as upper critical Reynolds number for both laminar and turbulent flows. The upper critical flow will be around 2800 for laminar condition and to 10 power 5 in case of turbulent condition. The flow in between 2000 to 4000, you term it as transition flow. In this laminar flow, as I told you, the viscosity of the fluid particles are very high and predominantly velocity will be very less. Why? Because the viscosity of the fluid particle dominates the flow. So, in this case, we get three different conditions. The first thing is, within the boundary of the pipe, whenever the fluid is flowing in a pipe, there will be some, whenever the fluid is flowing around a pipe, for suppose if I consider this as a pipe, when the fluid is flowing, there will be some shear at the boundaries and there will be the velocity profile distribution as well as shear stress distribution. See, when the high viscous fluid is been flowing in the pipe, there will be formation of shear stresses at the boundaries. The boundaries of the pipes, there will be some shear stress, where I am showing it as a linear approach. The linear graph here, that the boundary at this point and this point, you will be having the maximum shear stresses. At the center, that is at this point, you will be having zero shear stresses. The stress will be zero, that is nothing but velocity at the center line will be more, which will be dominating the shear stress. So, in laminar flow, the first topic what you are going to see is the shear stress distribution or shear stress in the motion of the fluid particles in the pipe. The next will be velocity profile distribution. Whenever the fluid is moving, that will be obtained with some velocity of the particles. The velocity of the particles will be seen how the distribution of velocity of the particles is happening in case of laminar flow. Generally, it will be a parabolic explosion or parabolic development in the flow. Parabolic development, the shear stresses will be maximum at the corners. As we discussed, the velocity will be zero, where the velocity was maximum at the center. So, velocity was maximum at the center, the shear stresses is becoming zero. In the parabolic, we can say that this is the center line velocity where you will be having the maximum velocity for the fluid particles. This is regarding the laminar flow. When there is change of velocities, obviously there will be change in pressure. So, the third topic what you are going to study in laminar flow is pressure distribution. The pressure difference distribution or pressure head distribution or pressure distribution, which was given by Huygens-Poiseuille equation. Huygens-Poiseuille was a scientist who gave the distribution of pressure around the pipe. So, this is the topics which you are going to study in laminar flow. In this laminar flow, we only concentrate on to three topics called as shear stresses, velocity profiles and the pressure distribution. When this laminar flow, we mostly talk about the circular pipes where the fluid is entering from the circular pipe and leaving from the circular pipe. A small concept to be remembered here is when we discuss a topic called viscosity, that is nothing but the fluid is flowing between two parallel plates. One plate is fixed and other plate is moving. That type of flows you call it as Coute flows. When two plates are fixed and the fluid is flowing between that plates, you call it as creeping flow. That is the two basic important points which you need to remember in case of laminar flow.